Hi friends, I would like to discuss some basic concepts of Python, where Python is used, what is Python, who invented Python, and what are the advantages of Python, where all it is used. Then I'll teach installation and then I'll teach basic programming fundamentals. Okay, so let's discuss about Python here. What is Python? Python is simply a scripting language in the sense line by line execution of the code, or it is called also called object oriented programming language. So Python supports both scripting and object oriented programming language, unlike Java. Java supports object oriented, and C++ supports line by line execution. So Python supports both. So it is either called scripting or object oriented programming language. So this Python was invented by Guido. So before going into programming basics, we'll just know what are the actual advantages of Python. Why not Java? Why we want to go to Python? So Python and Java has few similarities, whereas Python have few advantages. So for example, Java and Python both are portable, both are free source. Java also can be downloaded, Python also can be downloaded, both are free source. And even Java is simple and Python is also simple. Compared to Java, Python is more simpler, and memory management is differently handled in Java and Python. Similarly, dynamic typing is different for Java and Python. And interpreted language, this is interpreted language. So main advantages of Python compared to other languages are, you can simply say my dear India or my dear interpreter to for remembrance sake. So these three are main advantages of Python. So these are not, I mean, these are not so added in other, these are the added features in Python. So for example, memory management, how memory is managed internally, I'll just show here. So let's, 1 second, let me take a thick one. Yeah, so how memory is managed. So for example, I have written x equal to 5, and then I have taken one more variable y equal to x. So how this 5 is saved within the memory. So I will just show it here. This is called a memory location. This is integer value number 5. So this all, everything in Python is treated as objects. So integer is one object. Similarly, float is one more object. Float is other object. String is other object. So we have so many objects like this. List is also an object. So I will go into data types later. So everything in Python is considered as object. So when it is x equal to 5 is nothing but integer object. Integer object. So how memory is managed? So x is pointed to 5. When y is also is equal to x, so y is also pointed to 5. Okay, both are pointed to same memory location. If you want to check, you can directly check here. We'll go and check how it is. Example, I will just take an example. X equal to 5 and then y equal to x. So let's check id. So id of x and also check the id of y. So here it is showing the same memory location, which means both are shared the same memory location. X is also shared the same memory, y is also shared the same memory location. So we can see the both are pointing to similar memory location. ID here it will say the memory location of that variable, particular variable, what is occupied the memory location. And similarly, print is a function here in Python 3, because print is a statement in Python 2 without braces, 2x versions. I am talking about versions. So Python 3x versions, 3x means 3 in 3.1.1, whatever 3 or higher versions of 3. Print is treated as function, so you need to write braces here for print statement. I mean print function. As it is a function, we need to write braces here. Okay. So here print id shows the memory location, and So X and Y both are having here same memory location. So whereas in Java, if you treat in Java or some other language, so X is 5 points to here, okay, and Y is also 5. It's also points to different memory location, which is memory wastage here. Even though X and Y are both are similar integer objects here, but in other languages it will be shown in different memory location, which is memory wastage. So we need to write some different program for garbage collection or deletion, I mean reuse for of this memory later in further and or in future. So in Python it is treated in this way. Okay, so let's suppose here we have taken id of x. So let me zoom it so that it will be visible more clearly. Okay, so here I have taken a second. So here I have taken both id of x and id of y here. So let me take, let's suppose x, or let's suppose I will change the value of x to 10. So now let's see, or x equal to, let me take x plus 5. So what this will do, this will increment 5, actual value of x is 5, and then we have added 5. So 5 plus 5, so x, current x value is 10. I have saved the same 10 value into x. So what is the value of id of x and id of y? So let's check here. What is the value of id of x and id of y? See here, this is the third value. I mean, this is the print id of x value, and this is id of y value, which means id of y is doesn't change, it didn't change anything. So initially id of x and id of y both are pointed to same memory location, and that memory location name is, I will just write last 5 digits, 39296. 39296. So this is the memory location where initially x and y are pointed. So later when I change the x value to 10, so x is, now this is the value 10. So x, so this tag is removed from here, and this tag is attached here. Okay, so x is automatically removed, this tag. So x tag is automatically removed, and x is pointed to 10, whereas y is still pointing to 5. So y value, sorry, y, so y is still 296, whereas x value is 9456. So you are able to understand this, right? So whenever we are modifying the value of x, okay, so id of x and id of y initially pointed to same memory location, and when x value is changed or x value is modified, then id of x is modified automatically to 456, and y is still pointed to 296. So how it is modified, it didn't took any other memory location, it just removed the tag which is here, x tag, and this is 10 and this is 5. Y anyway it is pointed, this tag is removed and this tag is attached to here. Whereas in other languages, x is again taken into 10, and x is still will point it to 5 also. So this should be garbage collected there in other languages. So there it is, memory is, we need to manage it, but here internally it will be manageable. That is called memory location. So internally how memory is saved, I mean how memory is divided. If you take, this is the memory or this is the RAM, we consider memory as random access memory, whereas we will divide this RAM into stack memory, ST, and heap memory, HEAP, heap memory. So what all the variables will be saved here, x, y, etc. And what all the values will be saved here, x is also 5 and y is also 5. both are point. And then x tag is moved to 10, then this value will be removed and x is pointed to 10. So what about this memory? This memory is automatically removed by, garbage collector internally GC garbage collector internally managed by Python. Okay, then. So this is something about memory management. So now let's talk about dynamic typing. What is dynamic typing? So let me take here one more example, x equal to 10. So print type of x, type of x. So here I have just taken x equal to 10. I didn't told Python compiler that hey, my dear friend, my dear x, this is integer value. So you need to print the given data type of x is integer. I didn't told that. So how it got to know? So by the way, this type function is nothing but the data type. To know about what data type x belongs to, then we need to use type function. So type will say which data type. So x is of what data type? So x is of integer data type. I didn't mention anywhere that x is of integer. In other languages, if we consider Java, then we need to write int x equal to 10. Then only x is treated as integer value. Similarly, float y equal to 5.5. Then only y is treated as float. But here, simply in Python, this is one more added advantage in Python. Simply if we take 10 and just ask what is the type of x, it will give integer, which means it is dynamically taking the data types. So it is called as dynamic typing. Okay. Similarly, if I take x equal to 10.5, again it will say it is float. X equal to some Python, it will take a string because I have mentioned it within this. Okay. Other data types I will discuss later, list, tuple, and all. I am just talking about dynamic typing. What is dynamic typing? So this is called as dynamic typing. Okay. So then third, what is interpreted language? So Python is interpreted language because it will compile internally. So our source code, source code is nothing but the program which will write in English, whatever in Python language. So for example, I have taken one program that is test.py. I have taken one program that is test.py. Now this test.py, once I run this program test.py, internally this test.py source code is converted to bytecode or machine code, that is the .pyc. After compilation, it will create one compiled version, that is .pyc. .pyc is nothing but compiled Python program. So test.pyc it will create. We need not bother about this because it will handle internally. But in Java, this compilation also we need to do by using syntax javac, by using command called javac. If you think that program name is test.java. Okay. So this is for compilation. Again, for running, we need to write java space that program test.java, java space test.java. So we need to do two steps process in Java. Whereas here in Python, it is just a single step process. We need not do anything. We need to just do only run the program. So if we consider Python source code test.py, this is source code. This is source code. This is converted to machine code or bytecode. How it is converted? So it is converted as .pyc file, which we need not bother, internally it will handle. So test.py. This test.py will be there for a second. It will just compile and immediately it will run. So after running, you will get the output into console. So this is a single step process. We will write only one step, that is Python space test.py. That's all. So this is the only thing we've done. But internally, what it will do, it will create .pyc file, and then it will show the output into console. So this is the interpreter. So internally, the interpreter means only at a time it will take all the two steps. So directly, it is directly handling directly this, from this to this, it is handling internally. So this is nothing but interpreted language. So interpreted means it will just line by line it will execute, and just it will show the, if it is having any syntactical errors or something, it will show, it will compile and it will show that you have so and so errors, syntactical errors or whatever error, logical error, whatever, it will show there. Okay. So this is nothing but interpreted language. Okay. So this is about advantages of Python. Because of these three main points, Python is highly, I mean, it has so much of advantages. And one more advantage is it is very simple code. For example, if you consider print statement in Java, then we need to write system dot out dot print line. Then we need to write this is Java program. Whereas in Python, we just write print. This is Python. So just it will, if you write this print statement, it will show this is Python. That's all. This is for showing output on console. This is console. Console is nothing but output screen, whatever, wherever it is showing the output. And print is a function. So we need to write a braces here and then to mention the whatever. Okay. And then if you take the input, so here we can directly use input of whatever you'll write from keyboard, enter a number. So if I execute this, it will ask enter a number. So it is expecting input from the keyboard. Whereas in Java, again, we need to write some other big syntax. So Python is very simple to learn. Okay, that is one more advantage of Python. Next, we'll talk about installation of IDE. Either it can be Jupyter Notebook or PyCharm. So I have both in my system. So let me install Jupyter. Let me explain how to install Jupyter Notebook. If you are using Unix or Linux machine, then we need to use pip install Jupyter Notebook. First, you need to install Python or install Jupyter Notebook in Ubuntu or in Linux machine, whatever. So just open this and you can see the steps to install this. Conda install. So Jupyter Lab can be installed by using either Conda or pip. If you have Anaconda already installed in your lab, then you can use Conda. Okay. If you use Conda, you can install using this. If you use pip, you can install Jupyter Lab. And once it is installed, so you can go through this installation steps, how to do and all. Then once it is installed, you can go to terminal, click on the terminal, and then just type Jupyter-notebook. Then it will open automatically. It will show the link here, how it is opening and all. Even you can click this link directly, it will open a home page. So this is nothing but a home page where you can see all file running clusters and all. Okay. So you need to take the new version, Python 3 notebook. You can install Python 3 versions or higher versions, because Python 2 is already deprecated in the year 2018. So you can take Python 3 versions here. Okay. So I have installed Python 3, I think 3.4 or 3.6. Let me check. How can you check the Python version? Let me show you. So let me show you here in the terminal. Just type Python. So it will show here the version 3.7.3. Okay, so I have installed 3.7.3. So now 3 versions. So you need to take the Python 3 new notebook. I have already pressed this, so I have got this screen. Then if you are new program, then you can write the program name here, untitled 196. I am not writing anything here. And then you can even save that program, whatever you're writing here. It will be saved in the current path wherever you have installed Python, whatever. And then after installation, you can start opening every time using simple command, that is Jupyter-notebook. So here, whenever you want to install new cell, you need to press plus. For example, I am here, I want to press new cell, then I need to press plus. And you want to cut this one, you need to cut the selected cell. Okay. And you can even run by clicking this one, or you can use shift enter or control enter or shift enter, whatever command you can run. Sometimes it won't run properly, then you need to stop the kernel and again restart the again you need to run. See, now it is running properly. Okay, so you can stop the kernel sometimes. Okay, so that's all for today's session. So let's discuss basics of Python program in the next session. Thank you. And if you have any doubts or any questions, please comment below. Thank you.